Okay, we're going to tie together a lot of different ideas here. So we have trig, quadrants, radians, and special triangles. We're going to tie them all together with these simplistic questions, but we're going to try to find the exact values for them. So one of the key pieces is knowing what our special triangles are. But then we've got to talk about quadrants, and technically we're working in radians, and this all falls under trig, we could say. We'll take a look at question 1, I'll call it. Cos 4 pi over 3. Let's start with a little bit of a review of the Cartesian plane here, or the unit circle is what they usually use to refer to it, because it'll be very helpful if we think of this as a unit circle. A radian, I am going to do my absolute best here to draw a circle. I don't ever do a great job of it. I think those are 3, so let's do curve, curve. Oh, that was almost okay. Ah, that's pretty good for me. Okay, we got our circle here. We're going to work with something called radians. And I'm not going to do converting. We're actually going to try to make sense of this. This object here is a circle. Okay? So if I draw a circle, ooh, not bad. If I draw a circle and I have to measure the distance around the circle. So let's say I need to go start here and I got to figure out how do I get around here. Any ideas? What's that called? Measuring a distance around a circle? Circumference. Yeah, we don't call it perimeter. We call it circumference of the circle. And it turns out the circumference has a formula to it. Circumference is the diameter times pi, okay? And the diameter is the distance across that circle. But we can rewrite diameter because it turns out radians actually turns to be a very common way of measuring things with circles. So a radian is just half of the diameter. So for this to still be true, we say it is circumference is equal to 2 radians pi, okay? So whatever our radius here is, we multiply by 2 and times pi. Okay, a radian. What on earth is a radian? Well, it turns out in this unit circle, we've got this unique scenario. The distance from the middle of the circle to this edge here is the radius. And the distance from the middle of this circle to this part here is also the radius. Both of these would be r. We can take a measurement of a circle, of a curve, and this curve can be equal to those two. We would call that a radian, okay? That would be considered 1 radian. That's a simple idea, except that circles don't end up with whole number values when measuring circumference. It turns out that if we were to go a quarter of the way up to here, it's actually a not so nice number. It's like 1.6, blah, 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 blah. Okay? So instead of writing this real number that has a ton of decimals, what we'll say it was a quarter of the way around a circle. I'm going to rearrange the circumference idea here. I'm going to say, well, there's a multiplication rule. I can go in any order I want. 2 pi r. Well, if I were to go all the way around the circle, we can say that that distance is 2 pi. So a quarter of the way would be dividing that by 4. Well, 2 divided by 4. We can simplify that by 1/2 pi. And if I multiply my fractions, if I make that a fraction and multiply, I get pi over 2 is a quarter of the way. That's exactly what we measure here. We say it is pi over 2 radians. Okay, so we're using that measurement. This is 1 radian. Well, this is pi over 2 radians, or the same distance as a radius of a circle. If I want to get halfway around the circle, I'm going to go all the way here. Well, it turns out that would be half of 2 pi, which half of 2 pi divided by half gives us just pi. Oh, that makes sense. Pi, that's what we use for that measurement. And if we want to go all the way around the circle, we call this concept 2 pi. Now we always say it's radians because it is actually related to the radius of the circle, but essentially we're measuring circumference. So instead of using this degree here, still a ratio like the degree will be, we talk about circumference in cutting pieces of the circumference. Now, to cut things in a quarter, a half, or 3/4, which happens to be 3 pi over 2, and 3 divided by 2 is 1.5. We measure in fractions of a radian. That's what we're doing with this idea. So after that little bit of a recap, let's jump back to this question here. Cos 4 pi over 3. Okay. Let's go take a look at this. We'll make another unit circle. We said it was cos 4 pi, is that right? 4 pi over 3? Okay, let's think of our sections. We've sectioned this off into essentially a half, 1 whole, 1.5, and 2 if we go all the way around. Now technically these are all pi and they're measured in radians. We gotta look at this number. Which quadrant might that fall in? That'll give us some good indication. Well, if I take this, the number 4 over 3, I know that's greater than 1. 4 over 3 is greater than 1. I can prove that by making 1 a fraction, an equivalent fraction 3 over 3. Oh, that makes a lot of sense. So already I know that I have to be farther along than the second quadrant. I must be into this territory. I'm passing that. The next question becomes, is it greater than 1.5? Okay, well, if we think of 3s, I can plug this into a calculator and find out, and it turns out that 4 over 3 is actually 1.3 repeated, which is less than 1.5. So I don't actually get up to this part. So what I've just discovered is I am greater than this, but less than this value, which means I'm in this quadrant here. In this quadrant here, oops, I wanted a highlighter. There you go. This quadrant here is known as quadrant 3. Okay, so we know we're in this space. I'll color it in a little. We just don't know how far we're into this space. 4 over 3. Well, if I get to this line, this is the equivalent of 3 over 3 pi. So we're going 4 over 3. 4 pi over 3. So in other words, I'm just going to do a sketch of the line. I must be getting up to this line. How much greater or how much farther past this point is this point is the question. So I think of my fractions and I go, well, this was 3 over 3 and this one's 4 over 3. The difference here would be 1 over 3. And again, we have our pi, right? Because we're talking about a fraction of a radian. Well, what that tells us is I've now made a triangle. I have a triangle here. I've gone past it. My measure in radians here is the difference between these two numbers. The difference between them is 1 over 3 or pi over 3. Okay, I found my radian. Now maybe I don't work so well with radians. I actually tend to work better with my my degrees. That's not true for me, but let's say that's our case. I can draw my special triangle. I can go, okay, here's my special triangle. What do I remember about the special triangle? Pi over 3. I remember one said pi over 3. The other side would be pi over 6. So this might be something you have to memorize, this piece. And then where does that go from here? Well, this one, I think the opposite is 3. This is 1, and this is 2. Okay, I'm in this quadrant. This is pi over 3. If I remember, I think that's 60 degrees. Yeah. Is that right? Oh, then I've drawn this wrong, actually, if that's right. 60 degrees. Yeah, it is 60 degrees, which means I drew this wrong. Good. Good thing we fixed it. Maybe I do work better in degrees. Yeah. That would be root 3, and this would be 1. Okay, we got that part. So that means we're working with this angle. This is the angle we're talking about, 60 degrees, or pi over 3. We've drawn the triangle. What's the relationship? What's the ratio? Well, we're talking about cos. Cos, if we remember, cos x, or theta, whatever you want to call it, is equal to adjacent over hypotenuse. So my adjacent side is 1, and my hypotenuse is 2. So it turns out that cos 4 pi over 3 is the equivalent of working at this angle here, and it is the adjacent, so 1 over 2. Okay, there's one other piece of this though, and they've given me like a cast system, which really helps me make sense of this. What is positive in quadrant 3? Which of the relationships? Cast tells us we have C, AST, and tangent, which means cos is not positive. Okay, so I'm gonna say it's negative, but why is that the case? Let's look at our triangle here. Essentially what we're finding is we're finding this point along a circle. So if I actually draw kind of a circle here, that's not so wonderful. If I draw this circle here, I'm actually trying to measure the distance of this. This is a coordinate. This is an x coordinate and a y coordinate. Well, the x coordinate is actually the distance here, which is the bottom of our triangle. And if I'm talking about my x-axis, this is gone in the negative direction. So this is actually -1. And then the hypotenuse, we always say the hypotenuse is a positive value. So it's 2. So our coordinate is actually -1 and 2. And when I set up as a triangle, that's -1 over 2. So that's why we get these negative and positive relationships, okay? So So we kind of piece that together. We'll quickly jump to another, and I'm going to speed through the next two. Sine 11 pi over 6. All right, I'm going to make some inferences, but I'm going to go a little quicker this time. I still have my radians. I'm still talking about my unit circle. I got to go, whoa, that's supposed to be a circle. I got to go all the way around. I know that this is pi over 2. This is pi. This is 3 pi over 2. So 1.5. Oops, that's a 2. This is 2 pi. Okay, 11 pi over 6. Okay, that's for sure greater than this. Is it greater than 3 pi over 2? If I'm not sure, I can just take 3 pi over 2 and make it an equivalent fraction. How do I make it over 6? Well, I just think of, what do I multiply by? If I multiply by 3, 2 becomes 6. Great. I just got to do it to the top 2. Times 3, that becomes 9 pi. Our number is greater than that, which means we are definitely into this quadrant here. Are we bigger than 2 pi? Have I gone all the way around the circle? Well, 2 pi, if I take that, 2 pi, I got to make an equivalent fraction. So I can make it a fraction over 1. I got to change it into a 6, which means I multiply by 6. And very quickly, this will start to make sense. You'll go, oh, well, what's 2 of 6? It's actually 12. 12 pi. Okay, so we don't make it all the way around. So that means we go all the way to here, and then we're just shy. So we have some line that goes here on our unit circle. I have to make a triangle. Here's that triangle again. So my question is, what's the difference again? What's the difference from going to 2 pi from 11 pi? Well, I had 11 pi over 6. I needed to get to 12 pi, or 2 whole pi. So 12 pi over 6. If I subtract the 2, I end up with 1 over 6 pi, or pi over 6. Hey, that jumps right back to that other triangle we had. Pi over 6 is over here. All right, I've already drawn it. I don't got to do too much. I just got to think of that ratio. Let's jump back. It's sine, I think. Sine, yeah, it was sine. Okay, so the question asked me sine 11 pi over 6. Okay, which we discovered is this part, pi over 6. Sine is our opposite over hypotenuse. I got the exact same answer. I got 1 over 2 again. Last thing I got to check, what quadrant am I in? I'm in this quadrant here, quadrant 4. If I look at cast, C, A, S, T, coast is what's positive. I can go through the motions of figuring out my X and my Y, but if I just refer to cast, I know very quickly, okay, because coast is the only positive, this must be a negative answer, okay? And then your very last one here, cosecant. I don't know that one off the top of my head. The first thing I want to do is I want to refer to its reciprocal. I know this is a reciprocal. I'm going to change it into my regular values. So I have cosecant, what was that one again? Cosecant, 2 pi over 3. 2 pi over 3. I know cosecant has to do with sine, and it's an inverse. I can very quickly change this by calling this sine, and I just have to flip this fraction. Don't have to do any other work there. So that becomes 3 3 over 2 pi. Sorry. Is that right? Oh my gosh, I'm second guessing myself. Give me a second. Let's do this. I'll go 1 over sine 2 pi over 3. Oh my god, why is this escaping me? I can just flip it. Actually, what am I missing here? This is the argument. The argument doesn't change. I know what we could do. We know that this is a similar relationship. Cosecant 2 pi over 3. We know it is similar to sine 2 pi over 3, but it's actually just going to be the inverse of it. 1 over cosecant 2 pi over 3. We know those are equal. So what I'm going to do is I'm going to work here, and then I'm going to convert it to this after, because this is something that I'm familiar with. 2 pi over 3. If I go back to my chart, 2 pi over 3, well, 2 divided by 3 is greater than a half. So I know I'm past this, and it's definitely less than 1. So I'm in this quadrant here. I'm going to draw my angle down here. What's the difference? Well, let's take a look. What would the difference between 3 pi over 3 minus 2 pi over 3? That's going to just be pi over 3 again, which means we jump back to that special triangle. We had pi over 3. Hey, that's this guy here. We're talking about sine, which is opposite over hypotenuse. So we got root 3 over 2. Jump way back here. very quickly find out that sine 2 pi over 3 is root 3 over 2. Okay. We're in the second quadrant, CAS. S is positive, so we're good. We got a positive value. But the original question asked for this. So what we're going to say is cosecant 2 pi over 3 is equal to 1 over sine 2 pi over 3. We're going to use this value and plug it in for the bottom. We're going to end up with 1 over root 3 over 2. So I got a division of fractions, which is 1 divided by root 3 over 2. You can use a calculator for this part. I think most modern calculators will solve this. I'll quickly show you. It becomes a multiplication of the inverse, and you get 2 over 3. So it turns out that, oops, don't forget that root. Cosecant 2 pi over 3 is equal to 2 over root 3 in the end. Okay, so I know we sped up a lot in the end there, but we did quite a few different ones. That one question. There's a heck of a lot of info we went through, okay?